very much for this opportunity to talk to you. So I'm going to talk to you about assessing groundwater flood risk. I'm definitely coming at this with a kind of national perspective. And I'm probably going to talk more about problems in assessing flood risk and how hard it is to do than I'm necessarily going to give you the solutions and answers. But hopefully as we can move through the day and kind of focus in more on sort of experience on the ground, things will get clearer. So I work for the groundwater research program of the Geological Survey. We're not a very large program. We're about 50% funded directly by the government and 50% funded by research that we do, sort of generally on behalf of the government. So we've been involved in groundwater flooding now really ever since the 2000 and 2001 event. So I'll start with the definition, because I think that part of the problem that we've had with groundwater flooding, and the first thing is we've got to agree what it is. What are we actually talking about? So this is nicely involved, but captures a couple of things. So it's the emergence of groundwater at the ground surface or rising into man-made ground. So the rising into man-made ground is to cover us for the basements and the sewers and the buried infrastructure, which is often the part of the thing that's actually affected first. The other issue is it's outside the normal range of groundwater levels or groundwater flows. So groundwater always rises up to the surface. If it didn't rise up to the surface, we wouldn't have rivers. So a base flow river, pretty much any river that you're seeing with water in it in the summer, is a result of groundwater coming up to the surface. So it's a normal process. It happens all the time. So the flood element is something exceptional. And I think that those are some of at times those give us problems. If something floods every year, you're not going to, I would venture that it's not a problem for any of us. If it happens every year, it's an ephemeral stream. If it happens every 2 or 3 years, it's a bog, and nobody would be dumb enough to build on it. Well, possibly some of the cheaper developers, perhaps, but but I think having a common definition can help. And I talk a little bit about the history. Again, obviously, groundwater flooding is nothing new. It's been there it's been there forever. So this is the earliest quotation that I can find that's definitely groundwater flooding. This is about the flow from Assendon Spring, which is a spring above Henley. It flows about once every 10 to 20 years. It's a classic because there's no problem at Assendon Spring. It's in the middle of a field. Nobody's bothered by it. But the water flows down and it flows into Henley. And it's dealing with the water as it goes through Henley has been problematic in the past. So it's been around for a long time. 1674 is that quote. But what about I put here rediscovery. People didn't talk about groundwater flooding that much before 2000, 2001. That's really when I dare to say that it hit us as this is a thing that we should be concerned about. There was flooding in Chichester over the winter and other places on the south coast in the winter of 93, 94. And I sort of went back to see what we wrote about it, what was written about it. And it was, the groundwater mechanism was discussed, but the word groundwater flooding wasn't used. And it was approached very much from the perspective of fluvial flooding and surface water. And people were into the soil moisture deficits and excessive rainfall amounts, and that was what was causing it. And the groundwater perspective was sort of put to one side partly because it wasn't being looked at by hydrogeologists. It was being looked at by hydrologists with expertise in surface water. And as a hydrogeologist, a geologist, we weren't really looking at it either because it's a flood and we don't do floods. They're not our thing. So 2000 and 2001 winter sort of changed that because we had this major flood event near enough to London for politicians to care. And extensive clear, I can say that, they pay my salary, extensive clear water flooding over much of chalk outcrop. And it wasn't just in the south and southeast, we had some clear water flooding up into Yorkshire as well. There was some more flooding in 2003, and as a result really of 2000-2001, with a re-emphasis in 2003, DEFRA sponsored quite a large research project into groundwater flooding. What is it? How extensive can it be? We did quite a lot of research, so we had a project called Flood One, which was a joint EU-funded project between the Geological Survey here and our French counterparts, BRGM, to basically look at groundwater flooding here and groundwater flooding in France. And that really, out of that, we've had making space for water and the kind of policy development. Summer floods, 2007, highlighted groundwater and surface water interaction. We do a lot of research with the Environment Agency on that. But we do have a little bit of a gap. So we've had this flood in 2000, let's all panic. 2003, let's panic a little bit more. And then really, when it came to it, 9-10 years, and 9-10 years when people had, perhaps other priorities as well. So I think it's reasonable to say from a kind of academic perspective anyway, that we had our eye slightly off the ball, and I think some of the regulators were stretched. They had a lot of things to do, and groundwater flooding wasn't necessarily at the top of the list. And I'm going to come at the end of my talk to say why that might be, and one of the problems with this. So, if we want to assess risk, I fully accept that there are people in the room who can pull me up here, probably fairly hard on my use of word hazard and risk and vulnerability, but just for the sake of this talk almost. So, if we have a model, so what do we need to assess risk? Well, we need to think, where can we get groundwater flooding? So we have a conceptual model. We have an idea in our head. These are the circumstances when we could get groundwater flooding. And then we can ask, where does that model apply? So where do we get the conditions on the ground where that would happen? We then need knowledge of water levels. So we need to know where the water is. Maybe we need to know where the water's going to go to. If we have those two together, I can say something about groundwater flood hazard. Okay, I can say here is an area where you could get groundwater flooding. If I know a lot of detail about the movement of the water, I can tell you here's an area where you could get groundwater flooding once every 100 years or once every 250 years. We have the location of receptors. Where are the buildings? Where's the sewers? Where's the infrastructure? But we also need to think about adaptation. And adaptation in groundwater flooding is a big thing. People have built, the built environment of lowland England has been built around a lot of our groundwater flooding. Now, again, I must hesitate to say that people aren't dumb, but people don't necessarily build where there's going to be groundwater flooding. They build on the higher ground. They build, or if they have had groundwater, if they were flooded in 1674, they probably knocked the house down and rebuilt it 15 metres away and hopefully up the hill. People have adapted building styles. So in Oxford, there's a whole area of Oxford which is very vulnerable to groundwater flooding. People have adapted the building styles. So there are Edwardian houses with effectively built up on half basements, about a metre off the ground. The roads flood, the houses are fine. So if we take location of receptors and adaptation, we get the vulnerability, we put those two together and we get groundwater flood risk. So it should be easy. You should be able to come to the Geological Survey or civil engineers and we'll just say, yep, okay, here's the answer. So we have tended to work with two models. These are our conceptual models. So clear water flooding. Sorry, I'm not quite sure what that. So clear water flooding at the top, which is just, you've got water underground, it rains, and the water comes up. So water comes up, and as it gets higher, that little river there becomes that large area of flooded ground. Okay, so that's our clear water flooding. That's what happens on the chalk. And then the other area that we tend to talk about is river groundwater interaction. So you have this situation, you've got a river here, and you've got gravels on either side of the river, and you can get a situation where water moves out of the river, up through the gravels, and you've still got dry ground on either side of your river, but you've got water up on the floodplain. So that's Oxford, and is one of the influences in the flooding that was seen in West London last spring. So we've got those two conceptual models, and we can apply those conceptual models. We can take geological maps. This is one of the areas where we're sort of confident. We've got the conceptual models. We have geological mapping of the UK at 1 to 50,000. It's not perfect everywhere, but we've got it. So the bright green here is areas of rock where the flow of water is mainly through fractures, so it's mainly the chalk, and that's the classic area where you get what we call clear water groundwater flooding. So basically the South Downs, Wessex, Chilterns, we get it coming up through the chalk, less so up here because of the geology is covered over with some drift and impermeable deposits, but up in Yorkshire. But we can get groundwater flooding anywhere in the country. It's the kind of magnitude, frequency and scale and problem of it that is different. So what I haven't put on that map are the river groundwater interaction, which is sort of more or less anywhere where there's a river, there's some opportunity for there to be some interaction between the river and groundwater. So we're quite good at that, I think. We know where it applies. Where it gets harder is to come up with that hazard, we need to know what the groundwater level is doing. So how do we know what groundwater level is doing? Well, there's a national network run essentially by the Environment Agency and SEPA and DOE Northern Ireland. About 5,000 sites have water level measured at some time during the year. And I would go, I mean, it's a very approximate number, about 20%. There's about 1,000 of those where there's sort of high resolution data. People are monitoring the data frequently, not always in real time, because some of this will just have a data logger in it that sits there for 6 months and then we go and retrieve. But there's sort of high resolution. But there are issues with that. I mean, it's quite clear with that one. That's our favourite one. We're really lucky. It's in the back garden of the office. And it overflows, and it's great when it overflows because you can get TV cameras in and they love it. It's obvious there. I know where the water is. It's there. But actually, a lot of the sites, a lot of those 5,000 and a lot of the 1,000, they're not there for flooding. The Environment Agency they've never had a budget really for groundwater flood monitoring. They're probably in the 5,000, there are about 100 of those sites that were actually drilled because they wanted to look at groundwater flooding. The vast majority are about water resources and water quality. So they're not necessarily the right network, not necessarily the wrong network, but they're not necessarily the right network. And the other thing is, we may not have the highest levels. So if we're saying that we've got a 1 in 100, let's say that we're going to look at a 1 in 100 year event, we might perhaps decide that last year was a 1 in 100 year event or a more than 1 in 100 year event. But generally, 50 years or 60 years of monitoring is about all we've got at that kind of national level. So we've probably never seen a 1 in 100 year event. Well, logically, we should only have seen a 1 in 50 year event. I know my statistics are poor at that point, but so we've got to extrapolate to get the high levels, and that adds an extra. So I would say that this issue of knowledge of groundwater levels is, we're weak on it. If we knew really well where the groundwater levels were, then we could give you a much better idea of vulnerability, of hazard. So, obviously we can do it. We're never not going to be scared of doing it. So here's groundwater flood hazard. So southeastern Britain, this is the chalk, and the red areas are the areas where we think there's groundwater flood hazard. So we've taken a water level surface, we've modelled how we think that water level surface may rise, we've put the two together, and we're saying, here's where we think you could have some hazard from groundwater flood. So you might then go away from here and think, oh great, that's it. BGS or somebody else can tell me the answer, and that's wonderful. But what happens when you actually zoom in and look at it? So I don't know whether we have anybody here from Surrey. This is the Croydon area, and I've chosen this because it's obviously an area with some groundwater flooding, so that's useful. But secondly, because it shows you some of the problems that we suffer. So this particular product, and this isn't the only product, and I'll come to others, it's quite coarse really. It's on a 50-metre grid, and it tends to basically model more or less the whole of a valley bottom as being an area with hazard. So the red area is a hazard. You also note this, and you think to yourself, well, that's strange. Why have they got that strange boundary? And the answer to that is because that boundary is sitting on the geological map. So the geological map, that's a sheet boundary, sort of there. So they define things differently on that side from that side. So that's the conceptual model changing. So, it's not perfect because it's designed to be a national product. We're trying to look at Croydon, and we're trying to look at the Highlands of Scotland in the same product. So I can take the location of receptors. We need to think about that issue of adaptation. I don't know anything about it because I'm a geologist. So I know nothing about where things are adapted. This is this is East Meon, which is down in Hampshire and next to Hambledon. Now I chose that because I've not been able to find a nice photo of Hambledon, but the story in Hambledon, well, I don't know, there are lovely photos of Hambledon, surely, but not the one I was looking for. So the story of Hambledon is that Hambledon had a main street with a ditch like that, up until 1943 or thereabouts, when they started to need to drive big heavy tanks down the road. So what they did was they filled in the ditches to make the roads wider. That's one story, and the other story is that it had raised pavements and that they lowered the pavements, again, to make the road wider. But the long and short of it was that the community actually had adaptation. It had drainage built in. If you have a big drain like this, it's going to lower the water table. It's going to reduce, there's still a hazard there, but you're reducing the chance that the water will actually come up to the surface. And if the topography's right and the geology's right and the ditch is big enough, you can get the water away from that community. And so East Meon doesn't have the problem, Hambledon does have the problem, and the work that's going on in Hambledon at the moment is, in a sense, they're reinstating some of these ditch systems. The top picture there is Oxford. I'm sure there's a proposal for those allotments, which are nicely flooded there, to be turned from allotments into houses, because there always is. But essentially, you have the area there that's worst hit by flooding, and it is allotments, not houses. Now, that might just be coincidence, but I'm guessing it's not coincidence. It's not coincidence because people will have said, okay, that's the area that floods, let's do something sensible with it, like use it as allotments. And I've done some work where we've looked at the kind of topography and looked at the Ordnance Survey mapping, and we live in a completely artificial environment in lowland Britain. None of it is how it came out of the last ice age, and it's all humankind. We've moved the rivers around. We push rivers to the sides of floodplains. We canalise them. We move them around. We build land up. We build embankments. It's all artificial, and it's thousands of years of artificial. The drains and sewers are important. They can be explicit adaptation, but they can also be sort of natural adaptation, and I've stolen urban cast from ESI as a phrase. So urban cast, you've got a whole network of pipes and trenches. So you've got sewer pipes, water pipes, electricity, broadband, whatever. It's all dug into the ground in pipes and trenches, and water can flow down those. So what we actually see happen in a groundwater flood doesn't match necessarily what happens in theory because of all this adaptation. Rural land drains. What are rural land drains? They're action to reduce groundwater flooding. So here's the same area I had before, and I've just extracted all the houses, which are the lines in red, where there's groundwater flooding. So I provide that to Surrey County Council, and they say, great, thanks a lot. You've just told us that 50% of our properties are susceptible to groundwater flooding, and what are we going to do about it? And at that point, I'm slightly lost for an answer. We struggle to get the precision here. So this is, I've said reality in 2014. These are the areas where there was some groundwater flooding. So some of these areas had been picked up by the Environment Agency's flooding from rivers and seas data set, which actually has, I shouldn't put it on here, but it has a narrow piece of flooding going down to about here. It misses that out, didn't miss that out, and some of the properties that were flooded were sort of outside the footprint of the area. But, we're not seeing flooding here. We're not seeing flooding there. Is that because we've got our map wrong, or is that because adaptation in the landscape is such that that was an area that didn't flood? I mean, I'd probably go 70% we got our map wrong, probably because we got the water table wrong, and 30% adaptation in the landscape. But it is hard for us to be precise. We can be more precise, so we can go, here's an example, this is the Berkshire Marlborough Downs, so Newbury and Hungerford there, and Blueberry, Wallingford is up here. So what we can do is we can run a groundwater model. So a groundwater model actually doesn't just say, here's a conceptual model, here's the water table. What we can actually do is say, okay, if it rains at this point, this much water is going to run off into the rivers, this much water is going to go into groundwater. The geological conditions are such that water is going to rise that much. And we can do it. And we can simulate past events. So this was simulating the 2001 event and basically seeing, does the groundwater model get it right? And we can run it against future scenarios. So that's how we've done work on climate change. So let's rerun the model. Let's run it on a 2050 climate and see what happens. So we can do this, but there are issues. It's expensive. Most models have been done for water resources, not floods. And doing it in real time, so doing it in advance, it tends to be done as a desk exercise in advance. Somebody does it, writes a report, there you go. There is work going on running these models in real time. I think we'll get there. I think we'll get to the point where this is the tool that you will probably be using if you're in an area where groundwater flooding is a real problem, to actually understand sort of what's happening year on year. The other thing I should mention, I've been talking again from a geological perspective. So water comes up to the surface, but obviously once it's come to the surface, it needs to run off. Brighton here in 2001. The flooding happened on the railway line up here, so that was a problem in itself. It blocked the railway line, but houses that were flooded down here. And that was because the water that came up then ran off down beside the railway line and down the roads and flooded the houses. So it was a sort of consequential thing. So there's work going on. Some of the JBA and Jacobs have done some work on this, and I'm sure others have as well, on basically linking groundwater flood, so linking a groundwater model to a surface water runoff model or a pluvial runoff model to try and calculate the actual depths and velocities and problems. And obviously there's also work on linking different models together, because of course a flood isn't necessarily just groundwater, it might be groundwater and a river at the same time. This is your end of it, not mine. Local detail. I mean, when it comes to it, what I'm really saying is we can, in a grand scheme, we can predict where groundwater flooding is happening, but the detail comes from locally. Actually, this is a campaign group probably complaining that the local authority haven't done enough and by letting rubber ducks go down. This is a Twitter feed of mentions of the word flood. So this is, and it matches rainfall really nicely. So contoured Twitterness of help, I'm flooded. But that sort of local knowledge and village history and detailed mapping is probably at the end of the day, because of these uncertainties in water level, the only way forward. So I've got a piece of paper that I'll leave some copies out. There are several maps. The first one that was done kind of nationally, and I apologise if I've missed somebody's map. Jacobs in 2003-04 produced some groundwater emergence maps. I don't think they're still sort of, kind of marketing them as a map as such. We produced a map of groundwater flood susceptibility. It's got a very crude model of how groundwater moves. ESI have taken those groundwater flood maps and made them better by having an improved understanding of some of the interrelationships between surface water and groundwater, and added extra layers of knowledge about where flood happens. And JBA have a groundwater flood map as well, which they've just launched recently. And several other organisations, I may have missed some. I know that Ambiental, I was mentioning earlier on that Ambiental were using, I think it's the ESI groundwater map, and adding that to some of their surface water maps. So there are several places where you can go for this national level mapping. And, it's kind of the line there was the sort of early basic stuff, and then the consultants are adding in extra value and extra detail to that. And I'll just finish up by just talking about frequency, just very quickly. So when you talk about surface water floods, people say, okay, it's a 1 in 100 year or 1 in 1,000 year flood. We find it harder to do that for groundwater. So we've got limited historic records. If people aren't calling it groundwater flooding before 2000, that doesn't help. But we can look at hydrographs, we can look at groundwater models and meteorological data. So here's a really long record. This is the longest groundwater record that there is, as far as we know, data from 1836. So it's 178 years of data. So I've just picked up, so more or less at this level here, about 70, I can't remember what I picked it up was, that's about 3 metres above sea level. So at 73 metres above sea level, the water comes out the top of the well, more or less. So it's happened about 12 times in the last 178 years, which, okay, so that's, it's every 12 years, rather, that's happened. But I want to pick out those. 1, 2, 3. 3 periods when we've had 25, 30, 40 years without a flood, without the level going over. So this well gives us flooding in the Levant, which floods Chichester. But if we look at flooding in Chichester, the kind of book number, once every 30 years. And if we look at floods in Chichester, we've got 1874, which is there, 1994, which is there. It didn't flood in between that, or at least if it did flood, it wasn't recorded. So we've got, potentially, certainly periods of 30 or 40 years, potentially periods of 100 years without flooding. So that's that normal bit. And that's one of the issues that I can't give you an answer to. We've had 2, 3, 4, depending how you count, events within the last 15 years. Is that the new normal? Will it flood again this winter, or will it flood again in 5 or 10 years' time? Or will it not flood for another 30 years, by which time, I think we'll all be retired. No, not quite all. Several of you will not be retired. I will be retired. I'll go with that. We don't know that. Anyway, we'll try and forecast it. We'll try and say when it's happening. We'll try and say how long it's going, but we don't necessarily know. And here's one of my colleagues in his back garden, and that's groundwater. So thank you.